Okay guys, thank you very much. Let's start the session for today. Okay. For today, it's going to be chapter 2. It's called Kinematics in Linear Motion. Okay, it's basically all about moving an object moving in 1D, 2D, and 3D. That's what we're going to learn for today. Okay, now let me choose a color. Okay, benda-benda ni semua, right? It's extremely important. Kenapa? Nombor satu akan keluar UPS. UPS adalah ujian your US lah. Usually kalau physics dia panggil US, ujian summative, where it will carry certain amount of marks for your final pointer. Okay, so first thing for today we're going to learn linear motion. Linear motion is all in 1D. This is what we're going to learn. Okay, now sebelum kita further move on to learning whatever we are supposed to learn in this chapter, we got to know all the basics. Now, these are the basics and these are the definition and SI unit yang perlu anda tahu, and kalau dia tanya, this is exactly what you got to write. Tak boleh tukar-tukar, because usually in physics, they want you to be very specific in what you're talking about. That's number one. Number two, final answers always 2 decimal places. Okay? Right, these are the two things. Now, let's start. Distance. Distance is a scalar quantity. Kita dah bincang sebelum ni. Definition of distance. Length of actual path between 2 points. Okay. Let's say dia pergi dari sini ke sini. Tak kisahlah dia ambil route ni ke, macam ni ke, atau straight ke. You kena calculate slowly one by one. This is the route that it take. This is the route that it take. Tak boleh ambil shortcut. Itu nama dia distance. The whole actual path yang objek itu ambil to travel from A to B atau one point to another point. Okay. Now the SI unit is meter. Next, displacement. Displacement is a vector quantity. Jangan lupa magnitude ada simbol. Sorry. Positive, negative. This thing is very important. Direction. Positive atas dengan kanan, negative kiri dengan bawah. Okay? Remember that. Definition of displacement. Distance between initial point and final point in a straight line. Maksud dia tak kisahlah dia pergi dari A ke B macam ni ke, tapi what is the shortest way for or from the initial point to the final point? Yang macam ni kan. So calculate je lah yang shortest way. That is displacement. Basically displacement nak shortcut. Okay. Now SI unit dia juga meter. Okay. Benda ni sangat penting. Okay. You guys clear about it?
Yes.
Alright, thank you. Now, let's go to the second one. Now, let's try a question. Okay, this question tests you whether you know what's the difference between distance and displacement. Now, let's just try solving this question. Number one, baca dulu soalan tau. Jangan duk highlight. Macam subjek lain, maybe you can highlight. But for physics, baca dulu. You gotta know what chapter it is, what subtopic it is, and what they're talking about. Now, an object P moves 30 meter to the east, after that 15 meter to the south, and finally moves 40 meter to the west. Determine the displacement of P relative to the original position. Okay, now they're talking about north, south, east, west kan? Automatically draw. North, south, east, west, label. East, west. Okay, step number one. Step number two, read properly. Baru you kena tahu. Now, an object P. Object dia, nama dia P. Okay. Moves 30 meter to the east. After that, okay, maksud dia, dia tak bagi any initial point. So, you can safely assume initial point dia dekat sini. Tengah, origin. Okay. Sebab dia cakap after that kan, dia tak cakap before that. Okay. Now, let's read it again. An object P moves 30 meter to the east. So, maksud dia label siap-siap. Sini 30. After that, 15 meter to the south. Ini 15. And finally moves 40 meter west. 40 meter. Ni dah 30. Tambah 10 lagi. So, this is 40. Determine the displacement. Maksud dia, this is the initial point, final point. Label P. AB ni tak penting tau. Yang penting P ni. P kena label. Okay, now. Determine the displacement of P relative to the original position. Maksudnya dia nak cari displacement. Itu je kerja. Okay. Displacement you know very well adalah shortcut kan. Jadi shortcut yang paling senang you can see is here. Inilah shortcut dia. Tapi dia bukan calang-calang shortcut. Now, you can find this macam mana? Dah terang-terang boleh tengok sini. This is a triangle kan? The moment this is a triangle, can you use Pythagoras theorem? I think you can. Sebab dia right angle triangle. Okay, now. Sini 30, sini 40. Sini tinggal 10 kan? Sini 15. Cari ni guna Pythagoras theorem please. What is the answer?
$18.028.
Okay, 18.028. So, as I said earlier, physics 2 decimal place kan? So, 18.03. Unit dia jangan lupa meter. Tiada unit, tiada markah. So, meter. Okay. Yang ini betul. Tapi yang ini represent apa? Yang ini represent OP. Kenapa? Dia dari origin O and the object moving is called P. Jadi distance of OP adalah yang ini. Okay? Kena ada ni, kena ada calculation, kena ada ni, kena ada unit. Benda ni semua you guys do panjang-panjang, sometimes 1-2 markah je. Tapi tanpa membuat ni, you cannot move on to the next step. Now, ini bukan calang-calang soalan. Dia tanya displacement. Displacement, you guys know vector quantity. Magnitude dah ada. Apa yang missing? Direction. Jadi dalam session pertama, kita dah learn how to find direction. Direction is tangent theta. So, dalam physics, okay, this part penting. Dalam physics, your theta is not yang ini tau. Okay? You have to look it in a mathematical way. Boleh tak tengok yang ini Z? Dulu kan dah belajar kalau yang ini sini, yang ini pun sama. Right? So kalau yang ni kat sini, this the angle. Okay, this the angle. So, angle dia dekat sini. Kenapa macam tu? Sebab dalam physics, angle dia always towards x-axis. Is this one towards x-axis? No. This one. This is towards your x-axis. Kalau macam ni, ini towards x-axis. Not, let's say macam ni kan, not yang ini. Tapi you have to find the angle which is equal to it. Okay? Itu rule untuk physics. Always towards x-axis. Now, can you find the angle? Definitely yes. Dah tahu ini adalah angle. Tapi, nak ambil value apa? Kenapa nak risau? Tahu kenapa? Because this is a triangle kan? If you draw this, benda ni pun triangle. So value dia akan sama. Basically you're taking this angle. So when you're taking this angle, its tangent is equals to opposite over adjacent kan? Opposite dia adalah 15 per 10. Tangent theta equals to 15 per 10. Theta equals to tangent inverse 15 over 10. Remember dalam degree mode. Nanti we will learn something about radian mode and so on. Sekarang this one is in degree mode. So now, what is tangent inverse 15 over 10? What is your answer?
$56.31.
56.31 degrees. Okay, ini adalah angle tapi dia nak direction kan? So you must say to them 56.31 degrees from west to south. Kenapa? Dari west, okay, dari west, can you see the pointer over here? Okay, dari west ke south. Kenapa? Tadi kan kita dah cakap triangle ni is like this, kita kena ambil angle kat sini. So dari west, ini west, ke south. Okay, dari west ke south. Kenapa? Kita tahu angle ni and angle ni adalah sama. We cannot be taking this angle. Kenapa? Rule. Always take from the x-axis. Always take towards the x-axis. Okay? Yang ini tiada. You have to find something which is equal to this. Tapi there's another method tau. Kalau you guys nak senang sikit, what you guys do, you guys know this is the angle kan? Just draw another plane. Kan y-axis, x-axis ada, pernah belajar. Just draw another plane over here. You guys know, okay, this is the angle. Dah tahu all the measurement, get the answer. Tapi, to determine the direction, sama ada dia west to south or south to west, you have to use yang ini. Kenapa? Kalau guna yang ini, dia akan jadi from east to north. Tak boleh. You have to take this angle. Okay? Angle paling terdekat. Basically, paling selamat guna apa yang dia bagi. Dia bagi macam ni kan, guna yang ini. Jangan try to do something else from this. Okay? This is the rule for this kind of calculations. Alright guys. Any questions before we move on to the next one?
CJ,
Yes.
kalau jawapan dia kita dapat negatif,
Jawapan mana?
contohlah,
Oh,
tu
contoh.
sudut kita dapat negatif.
Oh, okay. Negatif. Okay. Untuk sudut, korang kena letak yang ini tau. Modulus. Jawapan akan jadi positif. Tapi, you have, yang paling clear adalah your angle stated in positive and then your direction. Yang ini yang menentukan. Yang ini yang penting. Let's say kan, dia cakap negatif. Kalau dalam macam ni, in your y and x, dah belajar dalam matematik, belah sini kan negatif. Belah sini memang negatif. Tapi angle maintain positif. Okay, your theta maintain positif. You have to write down from north to west. Atau, let's say yang ini negative 31 degrees. Yang ini kan negative 31 degrees. You have to write 31 degrees above negative axis. So this will be 31 degree above negative x axis. Okay? Jap. Let me open up a new page for me to teach you guys yang tu. Yang tu memang penting sangat sebab chapter 2 is all about angles and stuff. Okay, now. Let's say you have this kan. Kalau angle yang ini, dia akan jadi let's say 52 degrees lah. 52 degrees above positive x-axis. Yang ini sangat-sangat penting sebab you don't want to write positive 52 here. Angle, you have to write in whole numbers. Above positive x-axis. Kalau belah sini, let's say belah sini kan, 52 degrees above negative x-axis. Kenapa negative x-axis? Kan I said if anything left and down is negative. Similarly, belah sini kiri. Kalau you guys remember balik yang sesi pertama, kan kita ada belajar left and down is negative. So, kita juga belajar resolving vector. Resolving vector tu apa? Tengok x-axis dengan tengok y-axis. Now, untuk angle belah sini, y-axis dia positif menuju ke atas. Namun begitu, x-axis dia ke kiri. Jadi, automatically akan jadi negatif. That's why it's above negative x-axis. Okay? Now, kalau dekat sini, towards x-axis, there's no such thing angle yang ini. Angle yang ini salah. Okay? There's only angle dekat situ. Okay? This one will be, what will this be? Anyone? Just try.
Below negative x-axis.
Exactly. Below negative x-axis. Kalau yang ini?
Below positive x-axis.
Yes. Now, tadi dari awal I've told you towards x-axis. Towards x-axis. Kenapa? Sebab you want this positive x-axis. We are all talking about the x-axis. Ini paling penting. Okay? This one is very important. We'll go very detail on this when we come to 3D and all this motion masa dia mula bergerak. Yang ini belum bergerak lagi. Okay? Now, let's move on to the next. Okay. Now, this is the next part. We are going to learn on speed, acceleration, velocity and so on. Number one, speed. Speed is dia punya symbol V. Okay, V kecil tau. V kecil and that's all. Okay. Scalar quantity. Definition, penting. Rate of total distance travel. Speed equals to total distance travel over time interval. Unit meter per second. You can even write like this. Okay. Macam ni pun boleh. It's all the same thing. Okay, now for you guys to take note, untuk tahu atau let's say lah, sebab UPS memang memerlukan anda menghafal definition. Itu no doubt. So, you guys know speed is total distance travel over time interval. Now, rate dekat sini kan dari definition dia. Rate dia, I also make it equals to time. So, tak payah susah payah hafal formula. Susah payah hafal definition. Tengok je formula dia. Speed is total distance travel over time interval. Kan I cakap rate is equal to time. Sini ada kan perkataan time. Automatically, speed is the rate of total distance travel. Settle. Yang bawah, naik ke atas. Kalau ada perkataan time, naik ke atas, tukar pergi rate. Itu je. I'll teach you lepas ni, right after this slide, you guys will know why is this simple. Sebab banyak sangat definition. Alright? Rate, remember, ada perkataan rate, just equate it with time. Atau you guys tak nak buat macam tu, you guys boleh hafal definition, tapi hafal-hafal, try to avoid it. Better to faham. You guys hafal definition, lepas tu, you guys just relate rate ni with time, push the rate down. You guys boleh dapat total distance travel over time interval. Formula dia, settle. Okay? Now, moving on to the next part. Okay. This one penting. Sebab velocity will be involved in a lot of your motions lepas ni. Okay? Now. Okay. Velocity. Simbol dia V kecil dengan anak panah. Kenapa? Vector quantity. Ada magnitude, ada direction. Tanpa anak panah ni, salah. Okay? Now. Kalau korang masuk SEM 2, Mathematics, you guys will learn about vectors and you guys will know how important is this arrow here. This represents vector quantity. Okay? Now, bila nak guna arrow ni? Bila dekat soalan dia bagi sudah. Itu nombor 1. Bila tak payah guna arrow ni. Tak payah guna arrow ni bila the whole question is about velocity je. Tak ada kaitan dengan speed. The whole question asking about velocity, go ahead, write V saja. Kalau the question ada cakap tentang speed juga, you have to do this to differentiate between velocity and speed. Okay? Now, as I've said initially, velocity is a vector quantity as a unit meter per second. Okay, before I go into this, let's go into this dulu. Now, average velocity. Average tu, as we have discussed earlier, semua tambah bahagi dengan bilangan dia. Okay? Jadi, average velocity is the rate of change of displacement. Okay. Tunggu dulu dengan definition, tengok formula. V average. V kecil tau, bukan V besar. Change of displacement over time interval. Kan sini ada time. Tukar je pergi rate. Simple. Rate of change of displacement. That is how you master your formulas and definition. Okay? Ini formula dia, V average delta S atau total displacement, S is displacement tau, over total time. Alright? Now, that is for average velocity. Instantaneous velocity. Instantaneous velocity is, okay, sini average kan ada rate of change of displacement. Sini instantaneous. Tambah je instantaneous dekat depan. Instantaneous rate of change of displacement. Atau you guys nak differently, you guys can also write rate of change of displacement at an instant. Basically extract balik daripada keyword sini. Okay. Dia punya formula sama juga. V equals to ds over dt. Tapi apa beza ni dengan ni? Okay. Instant. At an instant. Masa orang cakap at an instant, automatically in your mind you have to click. Okay. Dia maksud dia specific. Maksud dia, I want to talk about malam ni makan apa. Maksud dia malam ni je. Bukan malam esok. So at a specific time or location. So physics mostly time lah kan. So dalam formula ni, you have to write very specifically the value of it. Okay. Dalam 12 saat, apa jadi? So 12 will be your time. Displacement, maybe 5. So 5 bagi 12, macam tu. Okay, that is the difference. Now, constant velocity. Constant velocity ni memang you have to pay attention. Kenapa? Graph will always confuse you. Now, constant velocity is basically object that move at uniform velocity. Uniform ni maksud dia sama. First second pun 5 meter per second. Lepas 10 saat pun 5 meter per second. Maksudnya dia constant velocity. Dia punya formula ds over dt atau displacement over time. Tapi jawapan dia akan selalu sama. Kenapa? Constant velocity. Alright? That is for velocity. Now, let me explain to you what did I write here. Gradient area under graph. Okay. Korang tahu kan, ini nama dia displacement over time graph. S ni boleh jadi X juga, okay? Ini displacement, okay? I write short form je. Ini adalah time. Now, apa yang penting? Unit. Displacement meter time second. Tanpa unit, kosong markah. Now, apa maksud dia? Let's say dia macam ni kan? Okay, let's say dia macam ni. Gradient, what did I write here? Gradient of displacement over time graph. Ini nama dia displacement over time graph. Gradient of displacement over time graph atau x-t graph is velocity. Okay. Macam mana you guys nak kaitkan? Now, dia cakap gradient kan? Untuk straight line, cari gradient guna triangle kan macam ni. Dulu dah belajar maths. Okay. Gradient juga formula dia y2 minus y1 over x2 minus x1. Okay. Now, tak payah kisah value. Tengok unit dia. Y-axis dia unit apa? Meter. X-axis unit apa? Second. MS negative 1. Jadi, betul tak dekat sini gradient of displacement time graph is velocity. Unit velocity meter per second kan? That is how you want to find. Let's say dia bagi graph, dia suruh cari velocity dia. Buat je gradient. Sebab you tahu gradient y over x. Y dia unit meter. X dia unit second. So meter per second, unit untuk velocity. There you go. Alright? That is number 1. Number 2. Number 2 is area under VT graph. VT graph ni apa? VT graph, let me just erase sikit Okay, I'll just erase okay, I'll erase part ni sikit so that I can draw the VT graph for you guys. Alright, now when we are talking about VT graph, same thing. Basically kan, V dash T ni is actually V T. Jangan lupa unit. Tanpa unit, tiada markah. Time second. Now, dia cakap area under graph is displacement. Let's say dia macam ni. Kalau macam ni, triangle kan? You kena calculate ni lah area under graph. Tapi, area tu length times breadth atau length times height atau length times width kan? Basically dia multiplication lah. Jadi, tak payah duk think too much. Just take unit untuk X. Unit untuk Y-axis darab dengan unit untuk X-axis. What do you get? Second boleh cut sebab negative 1 times positive 1. You get meter. Adakah meter unit untuk displacement? Yes. Kenapa dicakap displacement? Sebab velocity here is a vector quantity. Adakah distance vector quantity? Bukan. Displacement je. That's why dia punya area under graph adalah displacement. Okay, you guys clear about it? Any questions before we move on? Alright, now let's move on to the next one. Okay, now we are going to talk about acceleration. They're actually almost the same with whatever we have learned before, but then they're just a little bit different, okay? Now, acceleration sini vector quantity. Unit dia meter per second square, m over s square or m over s square, okay? Now, same thing over here, you have to know the definitions. Average acceleration, rate of change of velocity, okay? Now, let's have a look at the formula. Average acceleration, change of velocity over time interval. Ada time kan? Sama dengan rate. So, masuk definition, rate of change of velocity. That's all. Dia punya calculation formula dia dv over dt. Basically velocity divided by time. Okay? Now, sini instantaneous acceleration. Instant, at an instant. Maksudnya at a specific location or time. Jadi, what is the definition? Boleh ganti je dalam dia instantaneous rate of change of velocity. Or if you guys don't want, rate of change of velocity at an instant. Okay? You guys can use either one of the definition. Now, as usual, at a specific time or location. Sebab apa? Instant. Now, uniform acceleration. Tadi uniform velocity kan? Now uniform acceleration. Kenapa acceleration dia uniform? Sebab constantly increasing velocity. Remember, kalau velocity dia constant tapi dia tak meningkat, tiada acceleration. Tapi kalau velocity constant increasing, baru ada acceleration. What type of acceleration? Uniform acceleration. Okay, please remember that. Kalau meningkat secara slowly at the same pace, baru dia ada acceleration. Jenis apa? Uniform. Okay, dia punya formula sama je dv over dt, velocity over time, tapi jawapan dia akan jadi constant. Basically, setiap kali you akan dapat 3 meter per second square atau 4 meter per second square, no matter how many times you do. Okay, now that is uniform acceleration. Next, let's talk about deceleration. Deceleration, kalau dia tanya definition, just type alright there, negative acceleration, okay? Negative acceleration, why? Decrease in velocity. The moment there's decrease in velocity, bukan decrease in displacement tau, decrease in velocity, automatically, snap, is deceleration, okay? These terms are all very important to solve your upcoming questions untuk the next session. Sebab next session, we're going to learn on 2D and 3D, okay? Now, let's move on to the graphs. Graph dia cakap apa? Gradient of VT graph is acceleration. Now, sini V, sini T. Gradient cari macam mana? Triangle kan? So, V meter second negative 1. T second. Gradient tu apa? Y over X. Jadi, Y dia apa? MS negative 1 over S. MS negative 2. Jadi gradient of velocity time graph is, ini unit untuk apa? Acceleration. Exactly my point. Okay? Now, let me erase sikit. I erase dekat sini I'll just draw the graph here. Graph ni penting sebab sometimes boleh masuk 10 markah pun. Alright, now the second part, area under AT graph. Now, AT, okay, A is meter second negative 2, time is second. Nak cari area macam mana? Area macam ni kan, basically darab lah kan. Sebab nak cari area, MS negative 2 darab dengan S. Now, what will you get over here? Anyone?
MS negatif 1.
Okay, ms negatif 1 unit kepada? Yeah, velocity. Okay, jadi that is how you actually get your answers. Okay, now any questions before we move on to the actual graph? Yeah, any questions? Alright, now let's move on to the actual graph. Okay, inilah graph-graph yang you guys kena tahu for matriculation syllabus. These graphs are the ones that you guys have to know. Okay, let's go one by one. X dash t can also be S dash t. Displacement over time graph. Kenapa displacement over time graph? V dash t, velocity over time graph. A dash t, acceleration over time graph. Now, when the object is stationary, okay, let's say objek tu dah bergerak 4 meter, lepas tu dia stop je dekat sana. Untuk displacement time graph, ada value tau. Ini sebenarnya 2, 4, 6. 4. Okay, I said tadi apa? Objek tu dah bergerak 4 meters, lepas tu dia stop dekat sana. Dia bergerak balik tak? Dia tak bergerak balik. It just went 4 meters but didn't come back. So, you know very well displacement is a vector quantity. Dia pergi depan positive 4, dia tak datang balik, so tak payah tolak 4. Jadi stay dekat 4. Tapi dia stay, jadi masa masih bergerak. Masa, where can you buy time to get back the time? No such thing kan? Time still moves on. Tapi objek tu masih 4 meter forward. Tapi dia tak bergerak mana-mana. Jadi dia punya graph will be constant like this. Jangan draw dekat sini. Kenapa? This one means kosong. The object didn't move at all. Initially the object moved to up to 4 meters, lepas tu dia tak bergerak. Itu maksud dia. Okay? Now, unless dia cakap mula sekali pun, daripada mula pun dia tak bergerak apa-apa, baru kosong. Okay? Now, as stated earlier, stationary object, when something doesn't move, will it have velocity? Kalau susah nak cakap, or susah nak faham velocity tu, just kaitkan dia dengan speed. Kalau benda tu tak bergerak, ada ke speed? Tiada kan? The moment tiada, velocity pun tiada. Velocity is just to differentiate positive, negative. Basically ada direction. Okay? So, that's why the graph is flat over here dekat bawah, kosong. Ini baru kosong sebab it's moving at 0 meter per second. Jadi, tadi kita dah bincang, when something is not moving, does it have any acceleration? When velocity doesn't move at any moment or at any point, acceleration pun akan jadi kosong. Okay? Kaitan dia macam ni tau. Jangan jumble up anyways. It goes like this. One by one. Displacement, velocity, acceleration. That is how you have to relate it. Okay? That is for stationary object. Now, let's talk about uniform motion. Okay. Motion lain dengan uniform motion. Motion tu, dia boleh bergerak at any speed, at any time and so on. Uniform motion maksudnya, dia bergerak secara 5 meter per second in the first minute, last minute pun masih 5 meter per second. Secara uniform. Okay, gradually. Tapi not gradually increasing. Gradually constant phase. Okay. Now, dalam displacement, as we said, dia dah bergerak depan. We are not talking about moving backwards tau. Moving forward je. Dia dah bergerak depan. Okay. Lepas dia bergerak depan, it keeps on moving, tapi at a constant phase. Jadi, logically, dia akan move juga atau cover a certain area at a constant rate juga kan? So, that's why the graph is so linear macam ni. Okay? That is for displacement time graph. Now, for velocity time graph, why is it flat? Sekarang, dia ada motion, tapi dia bergerak secara uniform. Tiada tambah atau tolak motion dia. Dia bergerak let's say 2 meter per second. The whole journey is 2 meter per second. No such thing 3, no such thing 1. 2 is 2. So, That's why it's constant like this. Uniform motion. Tak boleh dekat sini tau. Kalau kat sini kan, it's 0 meter per second, which means the object is not moving. Okay? Now, acceleration. Kenapa acceleration the graph dekat bawah sini? Kerana tadi we dah bincangkan acceleration tu apa? It's when there is a fluctuation atau meningkat kepada velocity. Velocity ada tak meningkat? Tak ada kan, dia stay je. So, automatically acceleration kosong. Alright, you have to relate it like this. And remember semua vector quantity, okay? Now, last one, motion. Nah, ini baru motion. Tapi dia bagi tahu dah, with constant acceleration. Jadi when they say constant acceleration, try to avoid doing number 1 and number 2 dulu. Buat straight number 3. Kenapa? You already know how to relate from displacement to velocity to acceleration. And you also know how to relate acceleration back to velocity and back to displacement. So when it's given over here, motion with constant acceleration, tadi constant velocity, graph flat. Sekarang constant acceleration. Same thing over here, graph is flat. Dalam acceleration, the only difference is there's no such thing macam ni tau. Kalau increase in acceleration, dia macam ni. Decrease in acceleration atau deceleration, dia macam ni. Okay? There's no such thing as graph macam ni ke, graph macam ni, curve or something. For acceleration, it's always a flat graph. Okay? Kalau increase dia, macam ni. Decrease dia, macam ni. Alright? That's for acceleration. Now, dia dah cakap with constant acceleration. Sini dah 2. So, when it moves on back to velocity, dia constantly increasing. Sebab tanpa constant increase, you takkan ada acceleration. Kalau you nak draw macam ni, that is called constant velocity, no acceleration. You have to draw it linear-wise. So, now, what is the meaning of constant velocity? Maksud dia, you are moving out. Let's say korang mula nak lari 100 meter. Takkan korang nak lari dari 0 meter, pergi 50 meter, lepas tu balik 0 meter. Takkan menang piala tu selama-lamanya. 0 meter, you have to run until the finish line. Baru boleh menang kan? Sebab itu displacement bertambah. Okay, kenapa tak straight? Sebab dia ada acceleration. To reach the final point to win a match, you have to run faster. That is why displacement dia meningkat macam ni. Okay, itulah some of the analogies that we use kat matrix so that you guys understand. Okay, any questions for the graph before we move on to the example? All right, thank you. Now, last. Okay, this one, these are the type of questions for 2.1 tau, chapter 2.1. Okay, let's try this question. A toy train moves slowly along a straight track according to the displacement against time graph in figure 2.1. Okay, when you get a question like this, you have to look at what kind of graph. You're talking about displacement time graph. So dia boleh jadi ST atau XT graph. That's number 1. Number 2, unit. Sini cm. Jangan pandai-pandai tukar pergi meter unless dia tanya suruh bagi dalam meter. Cm, maintain cm. Sini second. Sometimes dia boleh bagi minute. Sometimes dia boleh bagi hours. Okay? Please have a look thoroughly towards the graph and the units. That's number 1. That's number 2, sorry. Next, let's continue reading. You guys tak faham graph ni pun tak apa, it's okay. Now, let's continue reading. Explain qualitatively. Now, what is the meaning of qualitative? When we are talking about qualitative, we are talking about the motion moving from one place to another place within a certain period of time only. Okay, dalam graph ni terang-terang dia pergi sini, lepas tu dia stop kan, lepas tu dia pergi sini. Maksud dia, secara kualitatif, anda kena explain dari sini ke sini dulu. Lepas tu baru sini ke sini. So 2 kali ni nak explain. Okay, let's answer question number 1 first. Explain qualitatively the motion of the toy train. How do you want to answer this? Okay, the answer will be, just tulis macam ni, 0 to 10 seconds. Displacement over time graph kan? Tadi kita dah belajar kalau displacement over time graph flat, apa maksud dia? Stationary object. That's why over here, you have to write 0 to 10 second, Sebab objek dia tak move, so we call it at rest. Okay, now continue. 10 to 14 seconds. 10 to 14 seconds, what happened? The train moves in positive direction. Dia tak turun, dia pergi atas. Sebab displacement tau. Displacement can also turun. Sebab kenapa? Vector quantity. Remember, kalau turun jadi negatif. Ini positif. So, the toy train actually moves in a positive direction. Okay, itu satu, direction dia. Nombor dua, secara unit. Kalau positively atas, korang realize kan? Kalau positively atas, sini constant velocity. Jadi you have to relate it. It moves positively in a positive direction with constant velocity of state d value. Itu baru kualitatif. Okay? So sini you guys can write the toy train moves positive direction, not right or left tau, positive direction. Macam tadi kita dah belajar graph positively above the positive x-axis, macam tu. Train moves positive direction at constant velocity of, okay. Sekarang berapa value dia? Can any one of you calculate for me from 10 to 14 seconds what is the value of constant velocity? Velocity is what? Displacement over time kan? Displacement dia berapa? 10 tolak 4 bahagi dengan 14 tolak 10. Kenapa? We are only talking about at 10 to 14 seconds. Jadi, berapa value ni? Anyone?
1.5.
Ya, 1.50. Remember, unit sangat penting. Meter per second. Okay? Ini cara nak jawab kualitatif. Itu A. Kalau dia bagi, let's say kan, kat sini, lepas tu dia bagi sini, sini, explain lah satu-satu. Sini, sorry. You have to explain one by one. Part yang itu, lepas tu part yang ini, lepas tu part meningkat, lepas tu baru part ni. One by one. Itu baru explain kualitatif. Okay? Now, okay, let me erase this here so that you guys can see. Okay. B. B is sketch a velocity unit. Check dulu unit. cm, sini cm. Second, sini second. Okay. Go on. Against time, second, sini second. Kalau sini meter kan, kena tukar automatic sini, meter. Buat dua graf baru. Okay. Tapi sekarang dia maintain. So, sketch a velocity against time graph. Okay. Buat dulu velocity time. Yang penting you tahu 14 to 10, 10 to 14 constant velocity kan. Move at 1.5. Jadi you already know paling maksimum dia akan pergi pun 1.50. Label dulu you punya y-axis. Automatically sini kosong. X-axis. X-axis you have to label time. Macam mana label time? Follow je. Sini 10, 14. Yang ini dua paling penting. Kenapa? Ini starting, ini ending. Time tidak akan berubah unless dia bagi unit yang berlainan. Okay? Nah, untuk sini flat. Kalau kita tengok balik displacement time graph, kalau flat, velocity time graph jadi apa? Flat, kat kosong sebab dia at rest. Okay? Kenapa at rest? You guys already did the qualitative analysis yang dia at rest. So automatically it's like this. Wait, I'll try using different color. Okay, automatically dia macam ni kat sini. Okay, flat. Now 10 to 14 dia move tapi at a constant velocity. Tapi jangan risau, dia positif. Okay, dia positif. Now dia move upwards macam ni untuk displacement time graph. So, untuk displacement time graph, kalau you punya movement upwards macam ni, you punya velocity time graph tak boleh dekat bawah. Dia dekat certain value. Tapi flat juga. Kenapa? Constant. You're moving at a uniform velocity. Jadi, you know 10 ke 14 dia move like this je. Okay, macam mana nak connect? Macam ni je lah. Okay, tapi apa yang penting? Have to do your marker. Alright, itu je untuk sketching graph. Tapi graph takkan jadi sesimpel ni lah. Always usually complicated graph. Okay, that is for B. Now, let's do for C. I'll erase sikit I'll erase sini juga. Okay. Alright. Okay guys. Now let's move on to C. C dia suruh cari apa? Determine the average velocity of the whole journey. Whole journey maksudnya 0 sampai 14. Tapi dia nak average velocity je. So when we are talking about velocity average, V ni kecil tau, bukan besar. You have to do, sini apa? Dia bagi S. Kalau dia bagi X baru guna X. Sini dia bagi S. S2 minus S1 over T2 minus T1. Kenapa? Sebab you know velocity is also equals to displacement over time. So ikut je formula dia. Dia cakap the whole journey. So S2. S2 maksudnya is the final point. S1 initial point. Over T2 final time over minus initial time. Okay? Initial time ni always 0. Kenapa? Takkan nak mula dengan 1 unless bagi graph mula dengan 1. Okay? Usually kosong. What is S2? S2 is sini. Okay, 10. Tolak 4. Kenapa? Dia mula dengan 4. Over T2, which is your 14, minus 0. Okay, you get the answer of, wait, I'll just write here, 0.429 unit centimeter per second atau cms negative 1. Unit penting. Okay, alright, itu untuk C. Now, let's go to question D. Sikit lagi nak habis. Alright, let's go to D. D is calculate the instantaneous velocity as t equals to 11 second. Okay, now, kan tadi we dah bincang instantaneous, at an instant, at a specific time or location. Dia dah bagi dah specific time. Jadi, formula masih sama. S over T, V equals to S over T. Apa yang beza? Sini, you have to know. Tiada 11 dekat sini. Tapi you know very well this is a constant motion. Apa-apa linear, gradient dia kan sama. Kita dah belajar dalam maths. Apa-apa yang linear, carilah gradient kat sini ke, jawapan dia akan jadi sama juga. Same thing over here. So, you guys ada value 10, 14, 10, 4 je. 11 punya value tiada. Jadi guna je lah yang tu. Sebab gradient for a linear graph is just the same for any position. Alright? So, untuk S anda boleh guna 10 tolak 4 bahagi dengan 14 tolak 10. Here you will get the answer of macam tadi 1.5 cm per second. Okay? Remember, graph tu penting. Kalau graph dia kekok macam ni, automatic tak boleh guna tau. Unless the graph dia linear, then you can use. You can buat logical assumption atau rational assumption that a graph of linear, gradient dia dekat mana-mana pun sama. Okay? Itu untuk D. Now, last question. For last question, I'm gonna erase this part. Okay? I'm gonna erase this part. Okay. Untuk last question, it's quite direct juga. Determine the distance traveled by the toy train. Now, distance, ini apa? Displacement. Macam mana nak determine distance? Okay. Tadi kan remember tak, kita dah sketch velocity time graph. Nak cari the total displacement atau total distance. Tengok tak sini? Area under velocity time graph is displacement. Okay. Kenapa kita boleh guna itu untuk soalan distance dekat sini? Sebab the whole graph is positively inclined. Maksudnya dia meningkat je. Okay? Actually, you can use for majority of the graph sebab usually calculation distance dia akan relate positive. Kalau negatif masuk, automatically itu nama dia displacement. Okay, so mengikut atau menurut you punya VT graph, velocity time graph yang you dah sketch dalam B, now you can find the distance is area under graph. Okay, tadi area dia is macam kotak je kan? Dia macam ni tadi. Okay kan? Sini kan kosong, so tak payahlah apa-apa. So area dia yang ini je. Ini area dia. Area dia apa? Rectangle. So rectangle dia 1.5. You punya y-axis punya value 1.5 dekat sini. Okay. Lepas tu darab dengan you punya sini. Sini adalah tadi 14. Sini 10. So 14 tolak 10. Jadi je 4 dia kan. Jadi 4 darab 1.5 akan dapat 6.0 cm. Bukan square tau. Walaupun dia area bukan square. Dia nak distance dia. Alright guys. Itu for this session. Any questions guys? Any questions? Alright, if there's no questions, as usual, I'll be giving you guys the homework. You guys can have a go, have a try. Try to pass it up before 9:30 esok pagi. Okay, you guys have 12 hours to do so. Okay guys, good luck.